let's say, you know, the listeners out there, they accept what you're saying. Yeah, privacy is important. People that are oppressed or marginalized, you know, they that's obviously a necessity for them. Um, so how is this achieved? Right, it's through something called zero knowledge, or it's through cryptography. At least zero knowledge is one of those one type of cryptography. So what is zero knowledge? So DarkFi uses zero knowledge, right? So what is zero knowledge or ZK?
Yeah. So it's a very good question because it's been like in this market that we're in now, ZK is like one of the big buzzwords. So like it's been used a lot by different projects and it means different things. It's not used in a reliable way. Um, so I would describe ZK, zero knowledge, in the correct way, like in the correct meaning of the term, is like a property. So we can describe something as having the property of zero knowledge. Um, and that like having zero knowledge, I will give a practical example. It's in a minute, but first I'll just say in a kind of high level way that it's a way of anonymizing information, um, like while still being able to prove the relationship between values. So that's a bit abstract. I am going to illustrate that in a sec. But first, I just want to say that ZK is used a lot, especially in Ethereum kind of ecosystem. We hear a lot ZK rollups. And it's important to emphasize that they use the word ZK, but these rollups are not zero knowledge. They don't have the property of zero knowledge. Um, they are there's two. So there's basically in the landscape of zero knowledge proofs, and there's two things you can do with a ZK proof. You can compress information into a tiny format, so you can it's what a property what's called succinctness, um, or you can hide information and like achieve anonymity or zero knowledge. So basically, with the succinctness, it's just a proof. It's not actually ZK. So, but it got called ZK because in the zero knowledge cryptography like design space, we have these properties like succinctness, but you can do succinctness without doing ZK. So what these rollups are is basically they're succinct proofs that something happened. So you can like prove the entire the entire Bitcoin blockchain in like a single transaction, just like one proof that says like it happened that way, and it's like for sure, there's no way, it's non-contestable. So you can do that kind of thing, and that's what the ZK rollups are doing. Anyway, I just wanted to clarify, DarkFi is a different kind of ZK. It's one that achieves the property of zero knowledge. So what do we mean by this property of zero knowledge? So many people, when they give analogies, they give metaphors. They start talking about caves, and I'm not great on those metaphors, but I'm not a cryptographer. I'm a programmer, and my favorite example from of ZK is a programming example. Probably because it's like just like the easiest for me to understand, but maybe other people are like me and they think in this like step by step way. So basically, the my favorite exposure to ZK was I wrote a demo like smart contract using the DarkFi smart contract architecture, which we can talk about later, but it's basically a way to create and deploy anonymous apps. And in like a few months ago, I made a demo version of an app. It's not an app; it's just a contract. But I made this demo thing because I wanted to show other devs what the process of the smart contract architecture was doing. And what that contract was, that proof was, we use these words interchangeably in DarkFi, is to prove a relationship between values. So it was to prove A plus B equals C. Now you can put any like numbers in there, but it has to satisfy that relationship. So like like we write out A like plus B equals C. So we can say like A is 2, B is 3, C is going to be 5. So we have this proof which enforces that relationship. So it says like undeniably A plus B definitely equals C with like no questions. Like proof says so. Like so we know it's legit. Um, However, aside from like giving us that information that yes, the relation is true, A plus B does equal C. This kind of method doesn't require us to reveal the values A, B, or C. So we're proving the relation of these values without actually providing those values. So yeah, imagine A plus B equals C, but without revealing any of the values, just revealing that the relationship with those values is deterministically true, like with no doubt about it. So that's like a very simplified version. But basically, we can use this as programmers in a highly extendable way. So we can use this to do anonymous computation, basically. So we can run algorithms where the output of the algorithm is like deterministically true with no questions about it. It's like it's verifiably true, without knowing any of the values. So that's like the basic property of ZK that we use in DarkFi to achieve anonymous transactions. And we talked a little bit earlier about DarkFi, but I didn't mention that on testnet we have transactions. We also have anonymous swaps between any currencies, and finally we have anonymous DAOs. So these are the kind of techniques we use. Is like we can have these values. The only person who actually knows what those values are is you. The only thing that the blockchain knows is like that things happen correctly, but it doesn't share any of the actual values themselves.